Hey guys, so today I'm gonna step you guys through how to create a either Google spreadsheet or a Microsoft Excel document, and we're gonna see what the benefits are to using a spreadsheet as opposed to using a calculator to do a whole lot of repetitive math really quickly. So I gave you guys a set of data with 5 cars and 5 timers timing each car, and then some things that I wanted you to solve for and determine using a spreadsheet. So let's go ahead and open up a new spreadsheet and figure out exactly how to do all this stuff. So we're going to go over here to Google Drive, and I'm going to do it with a Google spreadsheet, but basically it's exactly the same in a Microsoft Excel document. So if you choose to do it that way, completely fine. So I'm going to create a spreadsheet. And this is what a spreadsheet looks like. You can see that each of the columns is labeled with a letter. Each of the rows is labeled with a number. This creates a big grid. Why is this grid important? Well, it allows me to label each of these little boxes right here. Each of these boxes is called a cell. So this would be cell A1, this would be cell A2, this would be cell A3. Why is that important? Well, what it allows me to do later on is go back and use the formulas that I want by calling what's called calling back to, or looking at using the numbers that get put into these cells. So maybe I put a 2 into B2 and a 3 into B3, and I want to add those two together. Well, obviously we know 2 plus 3 is 5, but if I want Excel or the spreadsheet to do math for me, I can press the equal sign, and then I can click on B2, and I can do Shift plus and do B3 and press enter, and you can see that it's 5. Now, why might I do this? Well, now if I put in 245, well, I now know this is 248. Okay? It does the math for me automatically, changing the answer based on whatever values change in the two numbers it's looking at. So we're going to get rid of these 3 because they're not part of our thing. So what I want to do now is actually put in not the data yet, but I want to put in the column and row labels that are used. We'll put in the data a little bit later as we go through. So we have car number is the first row. We have timer number 1. We have timer number 2. We have timer number 3. We have timer number 4. And we have timer number 5. Okay, this is the data section. So we have car 1, car 2, car 3, car 4, and car 5. Okay, great. So now we have the basis for our data table set up with the 5 cars that we're looking at and the 5 timers that we have. So we have 25 empty cells where we can put our data, but we're not going to do that yet. We're actually going to start using the formulas in Excel, in the spreadsheet, to solve for some of the things we're looking for. The first thing it asks me to look for is solve for the average time it took for each car to do it. Each car to complete the 5-meter course. So how do we find averages? Well, you usually find averages by taking one number, adding it to the next one, 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 and dividing by the total number. So let's try that. How do we get this spreadsheet to do math? Well, equal sign. Okay, we want to add the numbers together. Well, we could type in the number from here, type in the number from here, add them all together, or we can just click. Let's click on the time we're going to put here for timer number 1 on car 1. We'll put plus, and we'll do this. We'll click on the next timer, and then we'll do it on the next timer, and then we'll do it on the next timer, and then we'll do it on the last timer. So we've now added all 5 of those numbers together, or told the spreadsheet to add all 5 of those numbers together. The next step for anything in Microsoft Excel, in finding the average for anything, is to divide by the total number of values. Well, we would want to divide by 5. So let's put in divide by 5. Here's my problem. Order of operations says do multiplication division first. So if you saw this problem in your math class, you would do B6 divided by 5 and then add everything else together. That's not finding an average. We need to make sure to add everything together first, so we do that by using our good friend parentheses. Parentheses are extremely useful in Microsoft Excel because you need to make sure you're clear as to what exactly needs to get done first. So let's press enter. And so we've got our standard basic averaging equation in there. Is this going to work though? Is this going to give me exactly what I want? No, it's not. And here's why. If I put in, say, 2 for, let's put in our first value for timer number 1 was 1.55. I look down here and I see that my average is 0.31. That's not right. If I have one number that's 1.55, the average shouldn't be 0.31. Well, the reason that happened is because B3, B4, B5, and B6 are still 0. So we're going to do 1.55 divided by 5. Not the best way to do it. We want to be able to calculate what's called running average. So we want it to calculate the average for us as we put the numbers in, as we gather our data. For something like this where the data is already there, might not be as important, but when you're doing your trials later on, you're doing the experiment, you're getting each individual data point, it's going to be important to find the running average as opposed to the average afterwards. So how do we fix that? Well, the nice thing is both Excel and Google Spreadsheet have an averaging function built into them. So instead of adding all of those together and dividing by 5, we can call on some of the built-in functions that are in Excel and Google Spreadsheet. So let's just start typing in the word average. And you'll notice that average pops up as one of my options to pick from. So I'm going to pick average. It says, okay, that's great. It's going to return the numerical average of a value in a data set, ignoring any text. Okay? So basically, it just needs to know what range it's going to look over. Which values do you actually want me to average? So we want it to average timer values 1 through 5. So we're going to take our mouse, we're just going to click here and drag. Oops, that didn't work quite right. Well, let's get that out of the way. Let's get back on the right side of the parentheses. We want to click right here on B2, and we're going to drag all the way down through B6. And then we'll press, you can close the parentheses, it will automatically close them for you if you press enter in both Excel and Google Spreadsheet. So let's just press enter and we'll see that we get an average time of 1.55, which makes more sense. Okay? The reason is because it knows that it only has one value in B2 through B6, so it's going to take the one value, add it all together to itself, 1.55 divided by 1 because there's only one value, and we get 1.55. Now when we put in 1.48, you'll notice the average changes and it drops, which it should because we're getting somewhere in between those two numbers. Now, you could have done all this with a calculator really quickly and pretty easily, and that's great. But why are we using the spreadsheet? Well, here's where the advantage comes in. I can actually copy this average formula from B7 right here all the way across for each of the individual columns. How are we going to do that? Well, we could do Command C and Command V and paste, copy and paste. Or we can use what's called the quick copy function. So if you see this little blue box in the lower right hand corner, it allows me to copy something from whatever cell I'm in across whatever range I drag it over. So I could click here and copy this straight down. I don't want that. I want to copy my averaging function all the way across through row F. Okay? You notice I get these hashtag divided by 0 with an exclamation point, basically saying there's an error because we're dividing by 0. All that is the fact there's no data in there yet, so I can't do any averaging. But you'll notice here in the first column, we have B2 through B6 as our possibility, as our data range that we're looking at. In the next column, you'll notice that it's shifted over, C2 through C6. In the next column, it shifted over again, D2 through D6, and so on. It's going to add one column, one letter, each time. Basically scoot along with wherever you pasted it to each time. Nice and convenient, because now when I put in 2.05 here for 2, it starts to find that. If I put in 1.25 here, well, it's starting to find that value for me. Okay, it's taking those averages in a running total as opposed to having to get all the data in and then taking the average. Okay, so we've got that set up. Now, eventually we'll put all of the rest of our data in and get all of our average times. But let's continue on with the equations. The next thing I asked you to find is the average speed. So if I look back over here at my Google Doc, I can see that the average speed is the distance it traveled divided by the time, or the average time in this case. So let's see, what do we need? Well, we have the average time, we don't have the distance. So we're actually going to put in a distance row right here. So we have distance. We know the distance is 5 for each one. So again, we use that little blue box, quick copy function. We click and we drag over to the right. Now each distance is set to 5 meters. Okay? There's a specific reason we do this, and you'll see I'll show you in a second why we actually put the distance in as opposed to typing it into the equation for average speed. So let's go ahead and create our average speed row. It tells me we're going to do distance divided by time. So I want to do math equals. Let's use our mouse. Where's our distance? Right here. It's 5. We're going to divide by the time, which is up here at B7, 1.515. Press enter. And there we go. Find out our average speed is 3.300, lots of other junk. And we'll deal with that later. Now again, just like before, just like with the average time, we can take our formula and copy it all the way over to the right. So let's highlight the blue square, drag to the right, and we see that we get the same kind of situation where the formula has just been scooted over each time. Here we have C8 divided by C7, D8 divided by D7, so on and so forth, making our way across. Okay? Now, why did I put this 5 here? Well, let's say we go back and we actually measure the distance. It wasn't 5 meters. Let's say it was actually only 4.5 for this car. We press enter, and now that one has been changed. If it's changed for all of them, well, that allows me to just click here and drag all the way across. And now each of the distances has been changed, so the average speed will change. But if you notice, the formula is still exactly the same. So I can go back and make distance changes anytime I want to get the values I'm looking for. So we're going to go ahead and put 5 back in as the distance. Okay, next thing we've got is average acceleration. So average acceleration, spelled correctly. We have a slight problem. We notice that average acceleration exceeds the size of its cell, so it's cutting over into column B. How do we fix that? Well, the nice thing is the spreadsheets always have shrink or expand to fit options. And what that means is basically it can shrink or expand the cell to fit the biggest or smallest piece of data in there. Basically, it'll make it so that you won't have anything carrying over to the next cell. So to do this, go in between A and B. You see in Google Spreadsheet, we're going to get this blue bar with a little black arrow. In Microsoft Excel, typically be 2 black lines will show up when you go right in between the two. You double click, and it automatically made column A wider, so that way average acceleration can fit. Okay, how do we find average acceleration? Well, we go back over here, we look at our sheet, we see that we're going to take 2 times the distance divided by t squared. So let's do equals, again, because we're going to do math, 2, because that's never going to change, times the distance. Where's my distance? Well, it's up here at B8. Click there. Okay? Divided by the time squared. So we're going to take the average time. How do we square it? If you don't know this already, the way to do squaring is you're going to use the shift and 6. You end up with this thing called the caret. Okay? You use shift 6, you get a caret, and we're going to put 2. Basically, that just means take B7 to the 2nd power. Okay? We press enter, and we get the average rate of acceleration calculated for us. Okay? And again, just like before, we click in the lower right, we drag to the right, and now our formula has been copied all the way across. Next thing we need to find is the kinetic energy. So it's 1/2 times the mass times the average speed squared. Okay. So first off, let's type in kinetic energy, except we have a problem. That problem is we don't know the mass. So we need a row for mass, just in case we go back and remeasure the mass to be a little bit different. So let's go back up here to kinetic energy, and we want to put a row above it. Go to Insert, go to Row Above, and voila, we now have a row, clean row right above. So let's title this row Mass, and we're going to put in 1.5 in the first column, and drag it all the way to the right. We end up with 1.5 for the mass for every car. Now we can go back down to kinetic energy and put in our formula. So again, we want to do math. 1/2 is also 0.5, so let's do that, times the mass, which is B11 right here, times the times the average speed right here. But that average speed has been squared, so do Shift 6 to get the caret, and a 2. So we're going to take 0.5 times B11, the mass, times the average speed squared. And press Enter, and we find out our average kinetic energy. And again, just like before, we can click in the little blue box and drag to the right. And our formula gets copied all the way across. So now we have formulas set up where as I start to input information, all of the values are going to change based on the new calculated numbers that come out. So I'm going to quickly finish the data table. A lot of times you'll be able to copy and paste data tables. Sometimes you'll be able to copy and paste some data tables sometimes. But in this case, that doesn't work cleanly, so we're going to instead just quickly type everything in. 0.98, 1.01, 1.04, 1.02, and last one 2.7, 2.65, 2.69, and 2.75. Okay. So now all our data is in. Looks good, except for a couple things. Here's some general things we're going to do to clean up all our data tables. First thing is all these numbers after the decimal point. Not going to happen in this class. We need to be cleaner. We need to look nicer. We need to be prettier. Plus, this is also giving us way too much precision based on the information we put in. So how do we fix that? So in class, we're going to learn about significant figures. However, for Microsoft Excel or Google Spreadsheet, it doesn't know what those are. So instead, we're going to actually change the number of decimal places. And since I no longer need my data table, I'm actually going to make my page a little bigger here because there's some tools I want to use that are hidden if I shrink it. First thing, let's go with 2 decimal places for everything. All our times had 2 decimal places, so let's make sure everything has 2 decimal places. So use your mouse, highlight everything in the data table. And you can see here we have these 0 to the left and 0 to the right buttons. They're in Excel too, look very similar. So we can either decrease decimal places or increase decimal places. Now, since everything here has random numbers of decimal places, it doesn't really matter where you start. Let's try decrease. You'll notice we actually end up taking it too far. We only have 1 decimal place, and we lost some of the precision that we got with some of our measurements. So let's increase it back by 1. And now you can see everything in the data table has 2 decimal places. Much cleaner, nothing that's dragged on for way too long, and looking strange. Okay? So this is pretty much pretty close to presentable data table, except for some things that will help make it a little bit more clear to the reader what's being presented. First thing that I would like you guys always to do is make your titles stick out. So your things that tell you exactly what we're looking at. So all of our column titles are our row titles and our column titles are going to stick out. We're going to bold them. This allows for the reader to know that that's not actually data, that's just part of kind of a descriptor for what's after it. You'll notice that average acceleration got cut off again, so let's go between A and B. We'll double click and it's back. Good, much better. Now the other thing you'll notice is that I have nothing to tell me what any of these values are. This is car number 1, 1.55. Okay, 1.55 what? Minutes, hours, seconds, nanoseconds, femtoseconds. What is it? Well, it's seconds. So let's put an S here, try and change it to seconds. See what happens. We have a slight problem. Our average time just changed. Our average speed just changed. Our acceleration just changed. Our kinetic energy just changed. Why did that happen? Well, 1.55 S is now a word. Because of that S being in there, because there's now text, it's no longer a number. And the spreadsheet is trying to do math on a word, and it says I don't know how to do that, and I'm not going to bother. So we can't put that S in the data table itself. Where are we going to have to put it? Well, we're actually going to put it over here in the row label. We'll put a parenthesis S. This allows people to know that everything in that row is going to be in seconds. Okay? And using copy-paste, we can actually attach it to each of these columns really quickly. And since it also goes to the average time, we'll do it that way. Distance, units for distance are going to be in meters all year long. Average speed units, meters per second. Average acceleration, we're going to do in meters per second Mass is going to be in kilograms, and the kinetic energy is going to be a unit called the joule. Okay, we'll get to that later in the year. Now everything looks great except for that one silly row again, average acceleration. My units disappeared, so let's go back between A and B, double click, and bring it back. Okay, so far so good. Everything looks really nice. Another thing aesthetically that I like with my data tables, especially with some of them, they can get a little kind of out of alignment, is I like to center everything. This allows you to know exactly where which column the data is supposed to be in. Sometimes it can get a little funky and it's hard to tell exactly where it's supposed to go. This right here looks like a great data table. The only thing maybe you might want to do, if you want to make sure the data sticks out a little bit more, so people know that that's where the data is, you could highlight each of these 5 column titles and underline it with the borders option. And you can do the same thing here with the lower border option. And now our data is pretty distinct. And we have our average time, our distance, our average speed, acceleration, mass, and kinetic energy separate from that, where we did some of our math. I know it might seem like a lot of prep work, but these data tables are going to be great because you're going to be able to calculate things right away as soon as you get one bit of information. It's going to save you a lot of time in case you have a mistake. We're going to use what's called the percent error calculation later in the year. And if your numbers are really far off, if you had to wait till the very end to know that, you might not know where you made the mistake or where the issue was. So just make sure that you're feeling comfortable with these data tables. And we're going to practice them throughout the year, so don't worry if you're a little overwhelmed still. We're going to practice them a bunch. We're going to use them all the time for analyzing all of our data. So hopefully this video was helpful and you're able to complete the worksheet.